Okay, here we want to match the parametric equations with the graphs labeled 1 through 6. Give reasons for your choices and do not use a graphing device. Let's take a look. We have x, which is equal to t to the fourth minus t plus 1, and y is equal to t squared. If we wanted to, we can create just a really quick table with a few different values. So if we take a look at some values here, let's go ahead and put in some negative values and some positive values. So if we try negative 1 to the fourth power is positive 1 plus 1, because that's minus and minus 1, so that gives 2 plus 1, which is 3. And then we know that negative 1 squared, or no matter what it is always going to give you a positive value. So if we try a negative, we can see that we get 3, 1. Now if we put in 0, we get 0 minus 0 plus 1, which is 1, and then we get 0. Okay, and if we put in 1 into that graph, then we get 1 minus 1, which is 0, which is 1, and then we get 1. So if we take a look at this, if we put in, in this scenario, we know that t is greater than or equal to 0, which means we're not going to have anything on the negative side. And we also know that we have, if you look at our graphs here, we can see that there's values on the negative side of the graph. Same thing here, same thing with 3, same thing with 4. We don't have it on 5, and we don't have it on 6. We do have it on 6, excuse me. And if you also notice here, we also have this point that could represent 1, 0. So it looks like for A represents 5. And just so you know here, it's t squared, which is greater than or equal to 0. So we know that 5 is matched with A. Let's take a look at B. At B, again, let's create our table so we can see what that looks like. So we have X, and then we have Y. Okay, well, if we plug in a negative value for negative 1, if we plug it in for X, we get 1 minus or plus 2, which is 3. And then we have the square root of negative 1, which is undefined. But if we put in 0, we get 0, and then the square root of 0, so we know it's going to be located at the origin there. Let's put in positive 1. If we put in positive 1, 1 squared minus 2 times 1 is negative 1. And then that becomes the square root of 1, which is 1. If we put in 2, we get 2 squared, which is 4, minus 2 times 2, which is 4, which gives us 0. And the square root of 2 is approximately 1.4. Let's try 3. If we put in 3, square it, which is 9, minus 2 times 3, which becomes 6. So that gives us 3. And the square root of 3 is approximately 1.7. Let's try 4. If we put in 4, If we square 4, we get 16 minus 2 times 4 is 8. And the square root of 4 is going to be 2. So it looks like when we're looking at this graph, okay, when we're putting in these values for 0, 1, 2, 3, from -1 to 4, it looks like in between 0 and 2, so between 0 and 2, we know that it is negative. So let's say if we put in 0.5, okay, so if we put in 0.5 into that function, so we're going to square 0.5. So let's go ahead and do that. So we got 0.5, square that, and then minus 2 times 0.5. That gives us negative 0.75. So we know that this gives us negative 0.75 here. And if we take that 0.5, take the square root of that 0.5, then we get 0.71. So what it's saying here is that we can see that there are values that are going to be negative for x in between 0 and 2. So we know that we've eliminated this one. And if we look at 2 and 3, we can exclude that. Same thing with 4 and 6. So that means we're going to look at 1, and 1 does kind of have a resemblance of a square root function. So therefore b matches with 1. So now what I'm going to do is, now that we've completed A and we've completed B, I'm going to go down to F. So let's take a look at F. So for F, what we have is x, which is equal to the sine of 2t divided by 4 plus t squared. And we have y, which is equal to the cosine of 2t over 4 plus t squared. Okay, now imagine if we eliminated the x plus the 4 plus t squared in the denominator. Well, then we would end up with x, which is equal to the sine of 2t, and y is equal to the cosine of 2t. And so we know that this represents a circle. We know that that would actually be x squared, y squared plus 1. It equals 1. And so therefore, we know that when we graph, we know that we're going to end up with a circle. And so now, if we apply the denominator of 4 plus t squared, what that does is it's going to continue to create more circles. But the thing is, when you're dividing it by a particular value, regardless of whatever the fraction is, it's going to make it smaller. So it's going to make smaller and smaller circles. Which one does that represent over here? Well, we can see that that represents number 3. So therefore, we can now say that F represents graph number 3. So now we've completed F. Now let's try E. So let's look at E. We know that E is x, which is equal to t plus the sine of 4t. We know that y is equal to t squared plus the cosine of 3t. Okay, so for part E, okay, if we actually eliminated the trig part of this, and this is x is equal to t, and then y is equal to t squared, well, this is going to form a parabola. Okay, and then when I add the trig elements to it, that means it's going to increase and decrease, increase and decrease. Well, if we look at number 4, okay, this forms somewhat of a parabola, right? And then you can see how it's increasing, decreasing, increasing, decreasing. So then we can say that E matches with number 4, or number 4. So now let's look at C. C, we have the parametric equations where x is equal to the sine of 2t and y is equal to y is equal to the sine of t plus the sine of 2t. So for the first one, we can see that the period for x is going to be 2 pi divided by 2, which is equal to pi. And then for y, if we wanted to substitute the value of t plus 2 pi into that function, we would get the sine of t plus 2 pi plus the sine of 2 times t plus 2 pi. And so therefore this is going to become the sine of t plus 2 pi plus the sine of 2t, which ends up equaling the sine of t plus the sine of 2t, which is equal to y. So therefore, we're going to say that the period for y is going to be 2 pi. So therefore, with C, we can say the following. We can say that those equations match with number 2 here. And the reason why is because x cycles through the values -1 to 1 twice. So it goes from -1 to 1 twice. And y cycles through those values only once. So it goes through once. So therefore we can say that C represents number 2. And therefore we can say that D, and let's look at those equations. So we have x is equal to the cosine of 5t. And y is equal to the sine of 2t. Okay, so we know that we've eliminated d, so we know it's going to be number 6. But let's just talk about that as to why. So let's take a look at the x equation. We can see that the period here is going to be 2 pi over 5, whereas the period for y here is going to be 2 pi over 2, which is equal to pi. And so we're matching that with number 6. And so x is going to take on the values from -1 to 1, and then from 1 to -1, before y takes on the values from -1 to 1.